Hello everyone. So today let's solve the problem 312 burst balloons, right? So let's see what the question states here. We are given n balloons. Yeah, simple. We are given n balloons indexed from 0 to n minus 1. Yep. So zero based indexing. Indexed from 0 to n minus 1. Each balloon is painted with a number on it. Each balloon is painted with a number on it represented by a array nums, right? So see here we have the nums array 3, 1, 5, 8. So the balloon is painted with the number 3, 1, 5 and 8 respectively, right? So we are asked to burst all the balloons, right? So we are asked to we are asked to burst all the balloons. Yep. So if we burst the eighth balloon, the particular balloon, they are saying, right? Eighth balloon, you will get nums of I minus 1 into I, this one into nums of I into nums of I plus 1 coins. Yeah. If we burst the eighth balloon, suppose saying 3 here, we will get the nums of I minus 1, nothing but the 3 minus 1 into nums of I, nothing but the into 3 actually. 3 minus 1 into 3 into 3 plus 1, nothing but here in this case 1, right? In this case, I plus 1 is nothing but the 1. Nums of I plus 1 is 1. So it will be 2 into 3 into basically 1. 2 into 3 into 1 coins. We'll get 2 into 3 into 1 coins, right? So this is fine. Yep. If I minus 1 or I plus 1 goes off the bounds of the array, then treat as if there is a balloon with a this one painted on it. One painted on it. Yep. So first we have this one. What do we call? 3158 here. Yeah. So here nums equals 3158 we have. So we will be considering this one. What do we call? Nums of I minus 1. First nums of I minus 1 into nums of I into nums of oh, for the nums, sorry, I explained wrong, I think. While considering this one nums of I minus 1, we have to consider this one. What do we call? uh, First, we have to consider the left one. See here, 3, 5, 8 we have considered, leaving 1. Next, we have to go with the nums of I. So we have to go with this one actually, 3 and 8. And then we have to go with the nums of I plus 1. Yeah. So this is fine. See, for this one, we have, actually, this doesn't work like that actually. I have misunderstood the question completely. So this one, if we burst the ith balloon, you will get nums of I minus 1 into nums of I into nums of I minus 1. If this one I minus 1 or I plus 1 goes out of bounds on the array, then treat as if there is a balloon with a 1 painted on it. So that's what they have given here. So first what we will do, we will consider 3158 entirely, right? So we will be going with the nums of I minus 1. So this is fine. So this will be 3 into 1 into 5. Yeah. So accordingly with what they have given. Next, we will exclude 1. We'll exclude 1. We will be going with a 358. We'll be going with a 358. So we'll be going with the same formula 3 into 5 into 8. Next, we will exclude 1 and 5 respectively. We'll be going with a 3 and 8. So we will be going with 1 into 3 into 8 here, right? So because they have given here, um, if I minus 1 or I plus 1 goes out of bounds of the array, then we have to treat it as there is a balloon with 1 painted on it. Yeah, so this is fine. Next we have 1 into we will be excluding 1 3 as well as the 5 actually, 1 3 as well as the 5. So we are left with 8. So we will be treating 1 and 1 respectively. So behind and this one, 1 into 8 into 1. So this one finally will be going with a this one 3 into 1 into 5 plus 3 into 5 into 8. So this one, when we sum up this one, we will be getting 167. Sorry, I misunderstood this one. Sorry. Yeah, this is fine. We have got the output 167. The same thing we'll be doing it for the this one as well, 1 and 5 as well, right? So yeah, this is fine, man. Now, so what we have to return, we have to return the maximum coins we can collect by bursting the balloons wisely. This is fine. Yep. Now let's move on with the approach part. So before hopping into the approach part, so let me tell you one thing. So we will be making use of the 2D DP to solve this particular problem, dynamic programming 2D DP. Yeah. So now let's discuss the DP idea by considering the first example, the same thing, and let's try to implement the same thing on the by considering the first example. Yeah. So here example we have here is 3158. So this one nums 3158 we have, right? So we will be making use of the 2D DP where DP of LR left and right. So is equivalent to the maximum coins obtained by bursting all balloons. Maximum this one coins by bursting all the balloons here, right? So this is fine, I believe. strictly between the indices L and R, strictly between the indices L and R, right? So in this case, it has to be 0 to 3, right? So this is fine. Exclusive. We will be adding the virtual, this one at both ends to simplify the boundaries here, right? So here we have been given 3158 actually. Before this one, before 3, we will be adding 1, and after 8, we will be adding 1 here in this case, right? For any interval left comma right, so this one we will be choosing, so this one actually. K greater than L and K less than R actually, which is the last balloon to burst in that particular interval. If K is the last, then coins from bursting K, this one last equals, this is nothing but A of L into A of K into A of R plus best from left, nothing but the L comma K, and also right K comma R, and sub intervals. So we'll be going with this one, dp of left comma R interval, this one we have considered, right? So R is equivalent to the max over K in L comma R of dp of L comma K plus A of L into A of K into A of R plus dp of K R plus dp of K R, right? So this is fine, I believe. Now let's consider the example one. Now let's consider the example one. So we'll just go with the example, this one actually. Let's go with this particular example with A equals 131581. Yeah, we'll go with 131581. Yeah. Uh, let's consider the interval 0 to 5, because see, we should be considering from 0 to 3, 0, 1, 2, 3 actually, but we will be adding 1 and 1 as per the idea, DP idea, right? So this becomes actually 0 to 5. We have to consider the interval from 0 to 5, yeah, whole array. So we'll try first K equals 1. We'll burst this one, 3 last, right? So we will be bursting this this one 5, 8, and 1, or 1, 8, and 5 respectively, right? So coins A of 0 into A of 1 into A of 5, right? So this one will be 1 into 3 into 1. So this will be equivalent to 3 plus dp of 0 into 1, that is equivalent to 0. Nothing but dp of 1, 5, best for 1 to 4, right? Similarly to the K of 2, K of 3, K of 4 will be performing the same thing actually, right? So dp builds up from the smallest interval to the larger, from 0 to so on, right? So final dp of 0, 5, in this case, this one basically we have to go with the dp of 0, 5 actually. We are going with the interval 0 to 5, right? So dp of 0, 5 will give the output 167. So similar to the first one that I have showed here. So the output that we'll get here is 167, right? So the output that we got here is 167, which is equivalent to the output that they have mentioned for the example one within the question. So this is fine. Our approach works absolutely correct here. So now, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Yeah. So what will be the time complexity and the space complexity here? The time complexity would lead to big of n cube. Yeah, the time complexity would lead to big of n cube, because we have big of n square intervals, and for each interval we loop over up to big of n choices of k, right? So we know this. So the overall time complexity would lead to big of n cube. And what will be the space complexity here? The space complexity would lead to big of n square as well. Um, because for the DP, we'll be making use of the DP table, right? And also it will be plus n for the padded array. So overall, we can just mention it as n square. So the space complexity would lead to big of n square. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n cube and big of n square respectively, right? So now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code. So the first one here would be, we'll be making use of the length of the nums, right, everywhere, most of the time, sorry. So let me assign this one to the variable n here. So I'll just give here nums of, so this is fine. The next part would be, let's build a padded array, the array A with with the virtual one at both ends. So we have to go with the left one and right one we have to add, right? So basically length will be n plus 2. So I'll just go with the padded array, this one virtual one we have to add. So I'll just assign A to the new int of n plus 2, right? So left one, right one, n plus 2 it has to be. This is fine. Just for the safer side. Now, left virtual balloon is equivalent to 1 and the right virtual balloon is equivalent to the 1. So I can just assign a of 0 to 1 and also a of n plus 1. Here, let me assign this one to the 1. The next one would be, let's go with a simple for loop, man. Because we have to copy the original nums into a of 1 to n, right? So that's what we need to do. So let me do one thing here. Uh, let's go with a for loop for int I equals 0, I less than n. Let me go with the I plus plus. So this is fine. So this one will be a of I plus 1. Let me assign this one to the nums of I. Let me assign this one to the nums of I. Yep. Now let's do one thing. We are done till here. Now let's initialize the DP array. All right. So we are going with the DP as I've mentioned. So I'll just go with DP. This one will be new int of n plus 2 and n plus 2 into n plus 2. Yep. Now we have to build the DP table. Yeah, we have to build the DP table as we are making use of the DP table. Let's build the DP table. Let's iterate increasing length so smaller subproblems are solved before larger ones, right? So let's go with here for int length equals to 2, len less than or equal to n plus 1, also len less plus. So this is fine. So within the for loop, let's go with for here int left equals 0. This one left plus len, this one less than or equal to n plus 1. Also, let me increment the left here. So this is kind of weird, man. Yeah, this is really kind of weird. So this one within the first, this one for loops, let's do one thing. Let's go with the right boundary of the interval. Yeah, so I'll just go with int right equals uh, left plus. Yeah, this is fine. Now let's choose the k as the last balloon to burst between left and right. So accordingly with what we had discussed in the approach actually. So let's go with the for loop here. So this one will be for int k equals left. So I'll be going with the left plus 1, sorry. So let me remove the semicolon here. This is fine. Now k less than right. Also, let me increment the k. Yep. Now within the for loop, what shall we do? Let's go with the coins when k is last actually. That is equivalent to the dp of left k plus a of left into a of k into a of right plus dp of k into right. So let me consider the variable name gain here. So this one is dp of left k. As discussed, we'll be going with the dp of left k plus a of left into a of k. This is fine into a of right here, this is also fine, plus dp of this one k right, dp of k and right. So this is fine. Now let's take the maximum, meaning here I'll just go with if gain here greater than dp of left, gain greater than dp of left and right. Then let me go with dp of left and right, or let me assign the dp of left and right to gain. Only if this one gain is greater than dp of left right. Yep. So this is fine. Yep. We are done with the almost we are done with the code. We are left with only one thing, that is nothing but we have to display the answer, or we have to output the answer. So we will be going with answer is nothing but the maximum coins bursting all between the 0 and n plus 1. Yeah, the whole array we have to consider. So here in this case, it will be return dp of 0 into n plus 1. Yeah, so this is fine. So let me format the code and let me hit the run button. I hope this works. Let's see. This has to work. What is wrong here? So I have, oh, I have closed this one here. This is wrong. This is fine. The same. So let's check here. Line number 18. So here, let me close this one here. button again. This works now. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly, man. So yeah, all the test cases are getting passed here, right? Meaning, whatever the code that we have written works absolutely correct for all the test cases. So this is kind of weird, actually. Uh, Problem is also kind of weird. The code is also kind of weird, actually. This is fine, man. So I hope the solution part is completely clear along with the approach as well as the complexities. Yep. For now, this is it. Thanks for watching, guys.